Welcome to this video. In this video, I will be presenting the findings and explanation about the Central Limit Theorem. Have you ever heard about this theorem? Well, if you have, did you know that in our daily life or in the working world, there are many problems that could be solved easily by applying this theorem? So, without further ado, let us get started. First of all, let me just show you the outline roadmap we are going through. We will be covering these 6 key points: the definitions of the Central Limit Theorem, how does the Central Limit Theorem work, history of the Central Limit Theorem, the definition and formula of the z-score, real examples of Central Limit Theorem, and conclusion about the Central Limit Theorem. Now let's jump into the explanation. Let's start with the question, what is the Central Limit Theorem? The Central Limit Theorem, or it can be abbreviated as CLT, is a statistical concept that states that the sample mean distribution of a random variable will assume a near normal or normal distribution if the sample size is large enough. In simple terms, the theorem states that the sampling distribution of the mean approaches a normal distribution as the size of the sample increases, regardless of the shape of the original population distribution. As the user increases the number of samples to 30, 40, 50, etc., the graph of the sample means will move towards a normal distribution. The sample size must be 30 or higher for the Central Limit Theorem to hold. Another definition about the Central Limit Theorem that if all samples of a particular size are selected from any population, the sampling distribution of the sample mean is approximately a normal distribution. This approximation improves with larger samples. This figure states a concept that if the population follows a normal probability distribution, then for any sample size, the sampling distribution of the sample mean will also be normal. If the population distribution is symmetrical, you will see the normal shape of the distribution of the sample mean emerge, with samples as small as 10. On the other hand, if you start with a distribution that is skewed or has thick tails, it may require samples of 30 or more to observe the normality feature. The next thing I'll explain to you is about how does the Central Limit Theorem work. The Central Limit Theorem forms the basis of the probability distribution. It makes it easy to understand how population estimates behave when subjected to repeated sampling. When plotted on a graph, the theorem shows the shape of the distribution formed by means of repeated population samples. As the sample sizes get bigger, the distribution of the means from the repeated samples tends to normalize and resemble a normal distribution. The result remains the same regardless of what the original shape of the distribution was. It can be illustrated in this figure. From this figure, we can deduce that despite the fact that the original shape of the distribution was uniform, a normal distribution, as the value of n or sample size increases. Apart from showing the shape that the sample means will take, the Central Limit Theorem also gives an overview of the mean and variance of the distribution. The sample mean of the distribution is the actual population mean from which the samples were taken. The variance of the sample distribution, in the other hand, is the variance of the population divided by n. Therefore, the larger the sample size of the distribution, the smaller the variance of the sample mean. The next thing I will share with you is the history of the Central Limit Theorem. The initial version of the Central Limit Theorem was coined by Abraham de Moivre, a French-born mathematician. In an article published in 1733, de Moivre used the normal distribution to find the number of heads resulting from the multiple tosses of a coin. The concept was unpopular at the time, and it was forgotten quickly. However, in 1812, the concept was reintroduced by Pierre-Simon Laplace, another famous French mathematician. Laplace reintroduced the normal distribution concept in his work titled Théorie analytique des probabilités, where he attempted to approximate binomial distribution with the normal distribution. The mathematician found that the average of independent random variables, when increased in number, tends to follow a normal distribution. Later, in 1901, the Central Limit Theorem was expanded by Alexander Lyapunov, a Russian mathematician. Lyapunov went a step ahead to define the concept in general terms and prove how the concept worked mathematically. The characteristic function that he used to provide the theorem were adopted in modern probability theory. Before we jump into the examples, we need to understand first what is a z-score. Simply put, a z-score, also called standard score, gives you an idea of how far from the mean a data point is. A z-score can be placed on a normal distribution curve. In order to use a z-score, you need to know the mean and also the population of standard deviation. Z-scores are a way to compare results to a normal population. For example, knowing that someone's weight is 150 pounds might be good information. But if you want to compare it to the average person's weight, looking at a vast table of data can be overwhelming. It means that a z-score can tell you where that person's weight is compared to the average population's mean weight. The next thing is how z-score forms its formula. When you have multiple samples and you want to describe the standard deviation of those sample means, or the standard error, you would use this z-score formula. This z-score formula will tell you how many standard errors there are between the sample mean and the population mean. The key here is that we are dealing with sampling a distribution of means, so we know we have to include the standard error in the formula. Now let us see the example taken from the real data. This type of example is also called greater than example. Based on the United States Census Bureau, in 2018, a certain group of welfare recipients receives SNAP, which is Supplemental Nutrition Assistance Program, benefits of $110 per week with a standard deviation of $20. A random sample of 25 people is taken. In this problem, we will find the probability if their mean benefit will be greater than $120 per week. Now let us see how the solution is going to be. I'm going to be using a pointer so you can catch easily what I mean. Step first, insert the values into the z formula. Based on the informations, we get 120 as the x-bar or observed value, 110 as mu or average of population, $20 as population standard deviation, and 25 as n or random sample. So it is going to be like this: z-score equals to, in parentheses, 120 subtracted by 110 divided by, in parentheses, 20 divided by square root 25, then divided by 20 divided by 5, then divided by 4, which is 2.5. And then the step 2. We need to look up at the table here. A z-score of 2.5 has an area of roughly 49.38%. As you can see, first we need to find where is the 2.5. Okay, here. And now let's see by this point of view, 0.00 here. But first we need to add 50% so we can get 99.38%, which is here, state here. The conclusion. This is the final section we are going to see. There are 4 main points that have been summarized from the previous explanation. Firstly, in probability theory, the Central Limit Theorem, or CLT, establishes that in many situations, when independent random variables are summed up, their properly normalized sum tends toward a normal distribution, even if the original variables themselves are not normally distributed. Secondly, the theorem is a key concept in probability theory because it implies that probabilistic and statistical methods that work for normal distributions can be applicable to many problems involving other types of distributions. Thirdly, this theorem has seen many changes during the formal development of probability theory. Previous versions of the theorem date back to 1811, but in its modern general form, this fundamental result in probability theory was precisely stated as late as 1920, thereby serving as a bridge between classical and modern probability theory. Fourthly, if x1, x2, until xn are random samples drawn from the population with overall mean and finite variance, and if x bar is in the sample mean of the first n samples, then the limiting form of the distribution is going to be like this. Z-score equals to limit n approaching the unlimited, in parentheses, x bar n subtracted by the mean divided by the population standard deviation divided by square root n. Well, this formulation is a standard normal distribution. Okay guys, so that's it for the video. Thank you for watching this video. I'm so sorry if there are wrong words or mispronunciations. Once again, thank you very much for watching and see you soon. Bye bye.